Yes. Hey, welcome back. Now let's solve the problem linked list matrix. So what does it mean? So you're given a matrix of n cross n size, and your task is to just construct a two-dimensional of the given matrix. So what does that mean? So you have matrix of 1, 2, 3, 4, 5, 6, 7, 8, 9. So what you have to do? You have to link it like this in the form of a mesh. So in other words, does that mean? So one is actually mapped to 2, which is the right, and one is actually mapped to 4, which is the bottom value, and consider 2 is actually mapped to 3, which is the right value, and 2 is mapped to 5, which is the bottom value. And yeah, and the question is pretty straightforward. And like just on reading the question, I think this is a very hard problem, and you might wonder on why it's given as medium, why it's given as easy. It is at least medium, and you might wonder like how to do it and all. But believe me when I tell, this is a very simple problem. And when you go through the time complexity, space complexity, you see that the expected time is also n square and space is also n square. That means that there are no special tricks to solve this problem. It's just a brute force way. So according to me, the best approach is to actually go through the entire matrix twice. And in the first round, create all the nodes. And the second round, link all the nodes. So what does that mean? So we'll go through the entire matrix once, and for each value of the matrix, we'll just create a node of that node of that I comma j. So for every position of I comma j, we'll just create a node of it and we'll store it somewhere. And when it comes to storing and accessing something very quickly, there should be only one thing which goes to your mind, and that is the dictionary. So what we'll do? First, we'll have a dictionary, and for each value in the matrix, we will go through the value, convert it to a node, and store that value. Like store the I comma j as the key, and the node itself as the value. So let's first do that. And one good thing is that the given matrix is of size n cross n. So there is no need to handle like for I in range length of matrix and for j in range length of matrix at the position 0. So what you will do? First create a node and just look at the given values. So you have a class node which takes in only one parameter, which is the value. And what you will do? You will inside the dictionary for every I comma j, you're storing the actual node. So now what has happened? You have your dictionary which has all the nodes. In other words, your nodes are in this way. So one which has none as none as right and none as bottom. Two which has none as right and none as bottom. Three which has none as right and none as bottom, and so on. And yeah, let's just try the next level also. And so what you have to do? You have to take one, and to one's right, you have to map it to two. You have to take one, and to one's bottom, you have to map it to four. You have to take two, and for two's right, you have to map it to three. For two's bottom, you have to map it to five, and so on. So how will you do that? So you actually have all the nodes, just linking it is left. So what you will do? You will go through I and j, like for example, for all the indexes of the matrices, and get the node at the current position and check if I plus 1 is less than length of matrix. If it is less than length of matrix, that means that the node at the position I plus 1 is also available to you because you have already created the node and stored it in the dictionary. So what will happen? So just let me write it out once. So first what you do? Get the current node. What is the current node? It actually be at the position I comma j. So now let's imagine. So you got the node 1. Let's take 0, 0 for now. So you got the node 1. You have to get the bottom node. So bottom, or it's called the down node. So what will be down node? Down node will nothing be D at the position like matrix, like the dictionary. It has the key of I plus 1 and the jth index as j. So take I plus 1, 4, and G 0 and J 0. So we'll come to 4. And what will be the right node? Will be actually equal to D at the position J plus 1 and I. So the right node will be I comma J plus 1. So like this is pretty simple indexing. And like I hope you understand how it works. Like you're just getting the right and the bottom node. But there is a catch over here. What if the node does not exist? For that you have to check. So what is the condition when the node will not exist? There you can either use two conditions. You can check like if I plus 1 is less than the length of matrix, else you can set it to none. And you can do the same for this also. If j plus 1 is less than length of or else you can set it to none. Mainly because when you are in 3, when you try to access the value of j plus 1, you will see that j plus 1 is out of bounds. And one good thing is that out of bound values are not stored in our dictionary. So it will be none. So what you'll do? You'll just set it to null. Mainly because you have to set that value to null. And so what you do? Kernode dot right, you will set it to right node. And kernode dot bottom, you will set it to bottom node, or which is down node over here. And it is not bottom, it is down. And believe me when I tell your entire algorithm is done. So what you have to do now, you have to return the node with the value which is at index 0 0. So where do you have that? You actually have that in your dictionary. So you just return it. So what you did, you just return 1 comma 1. Let's just compile and run it once. Uh, okay, I don't know why I did like this. It is like this. At the position I comma j, it's not I comma j. And again, it's current node. Just don't make sure to not make any typos like this. And yeah, it works. And let's just submit it once. And as you see, this is pretty simple. So like, what's the other condition which you can use over here to check if the current node is in bounds? Like the current node which you want to check is in bounds. Let's check for that is other condition also. So what you can do is actually, rather than checking like this, what you can do, if let's just backspace and do like this and exists in dictionary. So what you want to do? You want to check if the value I comma j. So for first you will check if I plus 1 exists in j, and j I comma j plus 1 exists in d. Else you will return none. You will not return none. You will just set the value of down node to none, and you'll just set the value of curve node to none, right node to none. So this should also theoretically work. Let's just check it out once. And yeah, it also works. And yeah, this also gets submitted. Yeah, that was pretty simple. And there is another way to do it, which is recursively. So what you can do is that you can actually go through each node and have a recursive function which will take the current node and check if the right and the down matrices are in the down indexes are in what you call are in range, like they're not out of bounds. And if it is not out of bounds, you will just set that value. You just make a new node and set it to the current node, and then you'll proceed. And yeah, that is actually pretty simple to do. And it's best if you try to do that once. And if you can't figure it out, then it is I don't know. Yeah, you guys try to do the recursive way. Mm, and that's all for it. And thank you for saying and goodbye.